Across our blue planet, a stark reality confronts us: freshwater scarcity. As populations grow and climates change, the demand for this life-giving resource intensifies. Yet, vast reserves of water lie untapped: the salty oceans. Desalination offers a tantalizing solution, promising to transform seawater into a lifeline for parched communities. But this promise comes with a caveat: the potential for disaster if not approached with meticulous care. Desalination plants are complex feats of engineering, each a testament to human ingenuity. However, their intricate systems and reliance on delicate natural balances make them vulnerable to a range of risks, from technological failures to environmental miscalculations. The consequences of overlooking potential hazards can be severe, impacting not only the project itself but also the surrounding ecosystem and communities it aims to serve. Imagine constructing a bridge without considering the strength of the materials or the force of the river's current. The result is almost unimaginable: a catastrophic collapse. The same principle applies to desalination. Thorough risk assessment, conducted at the very outset of a project, is not just advisable, it's essential. This meticulous process involves identifying potential hazards, analyzing their likelihood and potential impact, and developing strategies to mitigate these risks. By anticipating challenges before they arise, we can minimize negative consequences and ensure the long-term sustainability of desalination projects. Ignoring this crucial step is akin to sailing into uncharted waters without a map or compass, inviting disaster. In the arid Middle East, Israel's Ashkelon desalination plant stands as a symbol of the country's commitment to securing its water future. This technological marvel, once the largest of its kind, relies on a process called reverse osmosis. Seawater is forced through microscopic membranes, filtering out salt and impurities to produce fresh drinking water. However, a microscopic enemy threatened to derail the plant's success: jellyfish. These gelatinous creatures, drawn in by the plant's intake system, clogged the delicate membranes, reducing water output and causing significant damage. The oversight? An inadequate filtration system designed to prevent such biological fouling. This incident served as a stark reminder that even the most advanced technology is vulnerable to the unpredictable nature of the natural world. It highlighted the importance of comprehensive ecological assessments to identify and mitigate potential risks posed by local flora and fauna. Case study. To Tampa Bay, Florida, the price of ignoring biology. Tampa Bay, Florida faced a different kind of desalination dilemma. Faced with a growing population and dwindling freshwater reserves, the region turned to desalination as a solution. However, the chosen location for the plant, near a sensitive estuary, proved to be a critical error. The plant's discharge, a highly concentrated brine solution, was released back into the bay. This hypersaline discharge disrupted the delicate salinity balance of the estuary, harming marine life and impacting the local fishing industry. The ecological consequences were severe, underscoring the need for comprehensive environmental impact assessments before embarking on such projects. This case study underscored the importance of considering the full life cycle of a desalination plant, from water intake to brine discharge. It highlighted the need for responsible disposal methods that minimize environmental impact and ensure the health of surrounding ecosystems. Case Study 3, Carlsbad, California, Energy Demands and Environmental Costs. California, a state grappling with chronic drought, hailed the Carlsbad desalination plant as a beacon of hope. However, the plant's high energy consumption and its impact on marine life raised concerns about the long-term sustainability of this approach. Desalination is an energy-intensive process, and the Carlsbad plant's reliance on fossil fuels contributed to greenhouse gas emissions. Furthermore, the plant's intake system, which drew in massive amounts of seawater, inadvertently sucked in and killed marine life, including fish larvae and plankton, impacting the local food chain. This example highlighted the need to develop and implement energy-efficient desalination technologies powered by renewable sources. It also emphasized the importance of designing intake systems that minimize harm to marine life, and exploring alternative approaches like ocean wave energy to power the desalination process. Case Study 4, Fujairah, UAE. community opposition and cultural site preservation. Our final story takes place in Fujairah, United Arab Emirates. Here, a desalination plant was planned to support growing water needs. But early in construction, the project encountered resistance from the local community. The plant's location was near fishing areas and culturally significant sites. When community members realized the potential impact on their traditions and livelihoods, they protested, demanding that the project be stopped. The fatal flaw? A lack of community engagement and cultural risk assessment. The project team hadn't anticipated the significance of these sites to the local people, leading to legal challenges and a year-long delay. After extensive consultations, the team agreed to relocate the plant to respect local heritage and fishing grounds. This change increased project costs by over 30%, but it was necessary to regain community trust and proceed. Through this experience, the team learned the importance of early community engagement. Consulting with local stakeholders can reveal cultural and social risks that might otherwise be overlooked. Charting a sustainable course lessons for the future. The quest for freshwater solutions in a thirsty world is fraught with challenges. Desalination, while offering a potential lifeline, is not a silver bullet. As we've seen from these case studies, the path to sustainable desalination is paved with the lessons learned from past mistakes. These 4 cases highlight the critical importance of fatal flaw risk assessments in desalination projects. Whether it's understanding geotechnical conditions, addressing environmental concerns, or engaging with the community, each project teaches us valuable lessons. Thorough geotechnical assessments, proactive environmental compliance, and community engagement are essential to ensuring a project's success. By learning from these stories, future projects can avoid costly delays, improve community support, and protect the environment. As we move forward with desalination projects worldwide, let's remember the importance of identifying fatal flaws early. Together, we can secure sustainable water solutions that benefit both communities and the planet.